Alright, today we have topic 4.1, parallel lines and transversals. During this topic we're going to look at a lot of some new concepts and descriptions of the concepts. We'll also look at the diagrams of how they're drawn and go through several examples. Alright, so let's move on into the first part of our topic. We've got our concepts and the descriptions of such. First concept is parallel lines. Parallel lines for the description are lines. Lines in the same plane that do not intersect. They do not intersect. They have the same slope. And are equidistant. Equidistant. Now, basically, what this means, y'all should already know the general part of parallel lines. But for our diagram, we have two lines that run side by side. Let me get rid of that little extra there. Going to run side by side, two lines. They'll never touch each other. Their slope is exactly the same. They cannot be identified. When we identify these, they will have identifying marks such as this arrow on both of these. That is how you will see parallel lines identified. And, if you wanted to add to it, we can have, well, this is line L, and this can be line M. Yeah, a little too much there. Line M. Now, notice that we have both of the arrows going side by, or pointing in the same direction. We only have one arrow. That's going to show that these two lines are parallel. If you had two arrows here and only one here, well, that's not going to say that they're parallel. They have to have the same number of arrows on them in order to signify that they are parallel. Alright, so our skew lines, they are lines not in the same plane and are not parallel. Not parallel. And they do not intersect. Do not intersect. Alright, so they're not in the same plane. So let me grab a color over here. We're going to draw. I'm going to draw or put an attempt here at a cube to show that we have several planes. And this should also go over there on your diagram. So there's multiple planes in this cube. We have a total of 6 planes. So if I was to draw a line, there's lines that are not on the same plane. So I've got a line up here on this plane. And that can be my line L right here. And then I have a line coming up this plane. Now this line is, go ahead and finish it off. We'll call this line M again. Now, as you can see, this line will never intersect. They're on two totally separate paths. This one will be removed over to the side whenever it goes up past this one. But being on two different planes, they will never intersect one another. Alright, so now parallel lines. or parallel planes, excuse me, are obviously planes that do not intersect. So let's go planes that do not intersect. Now, if drawing these, I will redraw another one of these figures over here, or put an attempt to. Now, if we were looking at these, we're looking at planes that are parallel that do not intersect. Well, we can take this plane over here, which is all of this side, and it will run parallel with this side over here. That is what we're looking at in terms of parallel planes. We've got two planes that they will never intersect. If they're not intersecting, they're going to be running side by side. You can imagine just a box. You've got the two opposite ends. If you continue on forever, they will never intersect. Alright, so let's move to our examples. We have example 1. And example 1 says use the figure below to answer the questions that follow. You should see a figure similar to the one that you see here on your screen. And the first question says what lines are parallel to line AB. So here is our line AB. Now we want to know what lines are parallel to it. We have one here, which we label as line DC, or it could be CD, either or. And we also have one here at the very back, which is line EF or FE. Be sure to represent these correctly with the correct syntax, the lines over the top with arrows on both sides. Alright. What are the other sets of parallel lines? Part D. Let's see, we have lines here. Well, let me go ahead and let's grab a different color for that. Let's look at these lines. Right here we have parallel lines. So we can say we have lines DE. And here is our notation for parallel. You'll see two lines running in between our two sets, which then we can put here a CF. So this reads that line DE, that looks like a D, line DE is parallel to line CF. When you read that, that is how it is read. Alright, let's look and see if we have any other sets of parallel lines. We have this EA and FB. So line EA is parallel to line FB. Alright, and lastly, just looking for one more. We have right here, we have this line and this line that will be parallel. So we could say we have line DA, which is parallel to line CB. Alright, so that takes care of our parallel lines. Now let's look and talk about a pair of skew lines. Skew lines, let's look back, are lines that are not on the same plane and are not parallel. So they cannot be parallel. So going up here and looking at our skew lines, a pair that I can see, we have our DE right here Now it can't be on the same plane, so this right here, they will never intersect. So when we actually write these out, there's no symbol for such. You will actually will put here, we have line D E is, and we'll put just our words, skew to, and then we've got that line A B. Now there's several of these. We can continue on. You can have CF, and yeah, you have EA. There's several possibilities of what you could go off of for several different skews, but we're going to go ahead and move on to a pair, name a pair of parallel planes. A pair of parallel planes. Go ahead and grab a color here. Now, if I was going to look at parallel planes, there's two planes that I would see that could only be parallel, the back, front, and bottom. These three cannot, but if we took this side and this side, I think at that point we can say, well, we have two parallel planes. In order to name a plane, you do 3 points on that plane. So you would have D, E, A, and that is parallel to C, F, B. C, F, B. Once again, this parallel to symbol is used to signify we have 3 points labeled as our plane. So plane DEA is parallel to plane CFB. Alright, so let's move on to our next page, which should cover some more concepts. We'll look at another concept right here, a transversal. The description of a transversal, transversal is a line that intersects 2 or more lines in a plane at different points. At different points. Alright, so an example of such, we have our 2 lines. They do not have to be parallel. We've got a line here and a line here. So this can be any point. We'll say our line L and line M. Now, in order to draw the transversal of such, you will have this, another line that comes through. It intersects 2 lines in this instance, and it intersects them at different points. You'll have an intersection here and an intersection here. Now, you will form several angles that we've already know about. We have our vertical angles, our adjacent angles, our linear pair, but it also will form some more angles that we will talk about here in this next portion. So let me pull what is right below that up. You have a figure similar to what you see right up here, and it says when 2 lines are cut by a transversal, several types of angle pairs are formed. So here's our concept as our angle pairs, our alternate interior angles. Let's look at a definition of our alternate interior angles. They are 2 non-adjacent interior angles on the opposite sides of the transversal. On the opposite sides. So let me read this one more time. As a whole, there are two non-adjacent interior angles on opposite sides of the transversal. So with that being said, you should be able to note that they are not adjacent, so they are not going to be sitting side by side. So let's look at an example of such. Let's look at our examples here. Let's take angle 7. See what our alternate interior pair of our angle 7 will be. We have angle 7 right here. Alright, so it has to be on the interior. By interior, let me go ahead and color this in so that way we can see. This will be considered our interior. This is interior. And let me grab this. Anything outside here, all of this is our exterior. Imagine these two lines closing it in. What's on the inside, what's on the outside. So going back to our example here, our 7, it cannot be adjacent, but it has to be on the opposite side, so it has to be over here, and it also has to be in the interior. So the only one that's left would be our number 2. So 7 and 2. So let me put an angle 2. So angle 7 and angle 2. Alright. What are some other examples of alternate interiors? Well, we have 7, so now let's look at angle 3. Angle 3 and, alright, it's going to be on the opposite side, cannot be adjacent. It has to be on the interior, so angle 6. Angle 3 and angle 6. Alright, alternate exterior angles. Well, there are two non-adjacent angles, or non-adjacent exterior angles. Non-adjacent exterior angles on the opposite sides of the transversal. So it's very similar to our interior, except now they must be on the exterior portions. So let me go over here, grab this color, and let's take our number 1 up here. It's on the exterior. So angle 1. And, alright, it cannot be adjacent. It has to be on the opposite side of the transversal. If this is the transversal cutting it right here, it's going to be on the opposite side. It cannot be adjacent. The only other one that's left is angle 8. So angle 1 and angle 8. And similarly, we can put 5 and angle 4. Alright, let's continue down, look at some same side interior angles. So these are interior angles. Interior angles on the same side of the transversal. On the same side of the transversal. Alright, so let's go ahead and let's look at our interior angles. We've got 4 of them, 2, 6, 3, and 7. I'm going to take my first one, angle 2. It's going to be on the same side of the transversal, and it's going to be on the inside. There's only one that matches that. The same side and the inside. Angle 2 and angle 3. Also, we have angle 6. And that will be leaving you with angle 7. Same side, exterior. Well, that's knowing what we know from the interior. It's going to be exterior. Exterior. Get rid of that. Exterior angles on the same side of the transversal. So, looking up here, going to our exterior, we have 1 is on the exterior, so I grab my color for this. We have angle 1. And it has to be on the same side and the exterior, so then you will have angle 4. Using the same method, angle 5 angle 8. They're on the same side of the transversal. This 1 and 4 are on the left side, 5 and 8 are on the right side, and they're both exterior when dealing with this transversal. Corresponding angles. They are two angles that are in similar positions. Similar positions. Relative to the lines, and transversal. So, corresponding angles are two angles that are in similar positions relative to the lines and transversal. These two being the lines, and this being the transversal. Remember, the transversal is the line that cuts the other two lines. So, let's look at some examples of such. So, let's take one. One we have up here, and it's not dealing with anything that's interior. Let me go ahead and change my color over here. It's not dealing with anything that's interior or exterior. We can throw that away. We have to look at an angle that is similar relative to our number 1. Basically, when you're looking at this, you could say, well, our 1 is the top left. It's on the left side of our transversal, and it's on the top of our line. So here, the top of our line, left side of our transversal is going to give you angle 3. Now there's multiples of these. You can have, let's take angle 5. And let's look, it is on the top side of the line, and it's on the right side of the transversal. Top, right, is going to give you angle 7. So going off of that, we can do our other two that we can see. Angle 2 and angle 4. And then lastly we have angle 6 and angle 8. So that should get you started with the alternate interior, alternate exterior, same side interior, same side exterior, and then the corresponding. Remember, everything has to be the same. If it's on the top of the line, or if it's on the left of the line, top of the transversal, these things could be drawn. As an example up here, you could have your two lines running this way with your transversal cutting right here. And we could call this 1, 2, 3, 4, so on and so forth. Well, we're to the left of the line and the bottom of the transversal when you're looking at it, so 1 and 2 would be our corresponding angles. Alright, with all this being said in this information, I leave example 2, which has using the figure to classify angle pairs. The type will be what we have right here, the concept. You'll have either alternate interior, alternate exterior, corresponding, so on and so forth. And then it also wants to know at that point in time which line is being used and classified as the transversal. So if you can look at that, there's 4 different lines, any of which can be used as a transversal, but it is for you to determine, using the angle pair and the type that would be created by that, which line is the transversal.